Welcome, dear viewers. This is the first of a series of lectures on astronomy. What is astronomy? Astronomy is the study of the origin and fate of the universe we live in, and all objects found in the universe like planets, stars, and galaxies. It is also the study of the formation and evolution of the latter and other objects in the universe. Since more than 10,000 years back, man has always been fascinated by objects he was seeing in the sky. We can say that astronomy started with the existence of the Homo sapiens and maybe even before. In today's lecture on the contents of the universe, we're going to focus about certain objects in our galaxy, which are planets, comets, stars, and the interstellar medium. Before describing the objects found in our galaxy, we'll just have a very brief review on our knowledge of the universe. The oldest monument on our planet, which is a concrete proof that man has been observing the sky nearly 10,000 years back, is the Stonehenge in England. It is believed that it is most probably the Celt people have built the Stonehenge. The way the Stonehenge have been built, it looks very clear. They were very much aware and conscious about where the sun was rising and where the sun was setting in the sky. We also have a few other monuments, like the pyramids in South America, which is a concrete proof that the Aztec people in South America did have a sound knowledge of a few objects in the sky, like planets and stars. We also have one of the oldest Hindu temple in the world, which is found in Angkor in Cambodia. The way the temple has been built is a clear sign that there was a basic knowledge of astronomy which was inherent in the understanding of the people at that time. Last but not least, the pyramids in Egypt. So what you can see on your slide right now, in the center you have the great pyramids of Giza, surrounded by two smaller ones. The way the pyramids have been built and their orientation gives a clear sign that the Egyptians had a proper knowledge on what was present in the sky, like planets and stars, and also a few constellations. Before we go in the contents of our galaxy, it will be interesting to know how our knowledge of the universe has evolved with time. It is interesting to know that for nearly 15 centuries, men believed that the Earth was at the center of the universe, and all objects like planets, the moon, the sun, and the stars revolve around the Earth. It was called the Geocentric system. This system was brought about by the intellectual giant called Ptolemy. For different reasons, people did not want to go against this system. One of the main reasons was that Ptolemy was an intellectual giant and everyone was scared of going against his ideas. At the same time, it suited certain religious organizations at that time. In the 15th century, a famous astronomer called Nicolae Copernicus came up with the idea of the heliocentric system of the universe. So what is the meaning of heliocentric system? It is just that the sun is at the center and all planets and moons, the different moons which were known, were revolving around the sun. So it was a big revolution. It was like a déclic, as we would say in French, which was a revolution in our understanding of the universe. Suddenly, the Earth was no longer at the center of the universe, but it was the sun. Let's start by having a look at our solar system. As you can see on the screen, you have the sun and the different planets which revolve around the sun. We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Due to the latest definition of planets, the planet Pluto is no longer considered to be a planet, but it is considered to be a dwarf planet. On the same slide, you can see a picture of a comet. It is believed that we have trillions of comets which revolve around our sun. In the slide you have now, we can see the inner planets. The inner planets are basically rocky in origin. We have Mercury, Venus, Earth, and Mars. And on the slide, you can see the axis of rotation of the different planets. Now you can see the Jovian planets, which are Jupiter, Saturn, Uranus, and Neptune. They are basically gaseous planets. Their densities are very low compared to the inner planets. And you can see the rings of Saturn. If you look at the picture of Saturn, you can see that we have split rings. You can see a dark region here. So this is the first ring and second ring. Those rings are believed to be made up of very tiny rocks, which are found on a disk and which rotate around the planet Saturn. All of us have heard about the moon. So here is a beautiful picture of the full moon taken from the Earth, from a desert in US. Now, we are not the only planet which has moons. So our planet Earth has only one moon, but other planets may have more than one moon. Take an example, Jupiter. Jupiter, the biggest planet in our solar system, has more than 50 moons. And on your picture right now, you can see 4 moons of Jupiter. First one, second one, third one, and fourth one. And at the same time, you can see a kind of red spot on Jupiter, which is believed to be one huge cyclone found on Jupiter. Besides planets and moons which rotate around our sun, we also have smaller objects. There are smaller objects which are spherical in shape, but much smaller than Venus or Earth. Some examples are shown on your slide right now. This is called Xena, Pluto. We have Sedna, Quaoar. So those objects are called dwarf planets. They are similar as planets, except that they are smaller. Now, besides dwarf planets, we also have even smaller objects which revolve around our sun. They are called minor planets or asteroids. Now, during the last 10 years, many planets have been discovered which revolve around stars in our galaxy. And those planets are now called extrasolar planets. So far, we have discovered around 300, and each day we are discovering new ones. And according to the predictions made by astrophysicists, we believe that there might be more than 1 million extrasolar planets in our galaxy itself. A few of those extrasolar planets, and you can see one here on your screen, it is coming in front of its star. A few of them have characteristics very similar to our Earth. The instruments which are being used to detect extrasolar planets are still not very advanced. Engineers and physicists believe that in the near future, we might be building up new instruments with more state-of-the-art technology to be able to detect more extrasolar planets. So besides planets, minor planets, dwarf planets, asteroids, and moons which revolve around our sun, we also have one object called comet which revolve around our sun. It is believed that there are more than trillions of comets, but we don't see so many. Why we don't see so many? Because the period of revolution of the comets is very high. So it can take a very long time before the comet approaches our solar system. And when the comet is very far, it is very difficult to detect its presence. Most comets, we detect their presence when they approach the sun. Basically, in a comet, we have icicles, small particles of ice, and dust. And when the comet approaches the sun, due to the solar radiation, we can see the comet where particles will be emitting light. So on your screen right now, you can see Halley's comet, which looks like a broomstick. It was last seen in 1986. And according to astronomers, it has a period which is around 75 years, which means we will see Halley comet only in 2062. Let's see some more pictures of comets. Here is one of the oldest comets seen by man, which is very often called the comet of 1811. So it was a very peculiar comet in the sense that it was visible to the naked eye for nearly 260 days. Can you imagine 260 days? Let's see one more comet. This is a comet Hyakutake, which was observed in 1996. And it is a comet which has come very close to the Earth. If you take all the comets which we have seen in the last 200 years, it is the one which has come closest to our solar system. This is a beautiful picture of comet Hyakutake taken above a forest in Sweden. You can see the comet here. You can see the head of the comet and the tail of the comet. Another interesting comet which we saw recently was the Hale-Bopp comet in 1995. So you can see the comet, Hale-Bopp comet here. And the comet Hale-Bopp broke a record in the sense that it was visible to the naked eye for nearly 18 months. So it is a comet which has been seen for a longer time than all other comets. Here is a beautiful and rare picture of the comet Hale-Bopp. You can see it where the cursor is right now. So it's a coincidence. The comet has been pictured just above the Great Pyramid of Giza in Egypt. So this is a very rare picture of a comet above such a pyramid. Now let's leave our solar system. So what do we see in the sky when we look at the sky at night? We see basically stars. So here's a picture of taken from the Sahara Desert of different stars in the sky. Now, since more than 5,000 years back, different civilizations have been giving names to different constellations or different clusters of stars in the sky. And the names given depended on their imagination. Like here, this group of stars here was called Cygnus because it looked like a cygnus. So you can see different constellations. You can see Sagittarius. Sagittarius is a constellation which, whose direction is nearly towards the center of our galaxy. So basically when we look at the sky at night, we are looking at stars. But we are also looking in the past because light travels at a finite speed of 300,000 kilometers per second. So it takes time for light to reach us. So when we're looking at the stars at night, we are actually looking in the past. This is a picture of our Milky Way. Milky Way is our own galaxy. This is the center of our galaxy. So this is a region in our galaxy where you have the highest concentration of stars. So what you can see in the picture here are billions of stars which are found near the galactic center. Now this picture was not taken using an optical telescope. It was taken using an infrared telescope. One thing, dear viewers, you should realize, reality is not restricted to our senses. There are so many things in the universe, so many objects which exist, which we cannot see with our eyes, which we cannot see even by using the most sophisticated telescopes. So we have different telescopes like the infrared telescope, X-ray telescope, which can look at different regions, different objects in the universe using a different frequency. So this picture is a picture of stars in our Milky Way, near the center of the galaxy, which you can see near the cursor, in the infrared region. Now, dear viewers, you must be asking, why am I showing trees in an Amazon forest when I'm talking about stars? Don't worry, I will explain the analogy. When we're looking at trees in a forest, what are we looking at? As you can see, it's a beautiful picture of the Amazon forest in South America. We're looking at trees, at different species, different types of trees, at different stages of their evolution. So similarly, when we're looking at the sky, we are looking at different types of stars. And we're looking at different types of stars which are found at different stages of their evolution. So you can see the analogy at looking at trees in a forest and at looking at stars in the sky. Stars also have a very peculiar characteristic which makes us think of we human beings. We human beings, we are born somewhere in space-time. We have a life, it can be between 50 and 100 years, and then we die. Stars also have not always existed. They are born somewhere in space-time. They have a life, but their life will be a few billion years, and they also die. Now, the way stars die depends on mainly on its initial mass. This is a diagram which is called a HR diagram. Dear viewers, you don't need to know everything about the HR diagram, but what I want to show you on this diagram is, you can see different parts here. You can see one here, the yellow one, the red one. So those are different evolution of different masses of stars. So this region here will give you the evolution of stars having masses 30 to 50 times the mass of our Sun. This part here will give you the evolution of stars having around 10 times the mass of our Sun. And here the yellow circles which you can see here, it is a path taken by stars having masses similar to the mass of our Sun. So as you can see on this part here, at some stage during the evolution of our star, it will become a white dwarf. And it will become a white dwarf in a few billion years. You don't have to worry about it, dear viewers, because we won't be here at that time. Some stars which are heavier than the mass of our Sun, they die and become a neutron star. Some of them, they die by becoming a black hole like here. So the more massive stars, they die by becoming black holes. So to summarize this HR diagram, it's not difficult to understand. The death and what a star is going to be finally depends on its initial mass. Now, most stars which we see in the sky are found in clusters. What is a cluster? A cluster is a group of stars which come together due to the force of gravitation. As you can see on the picture here, it is an open cluster of stars. All those bright objects here, you can see. Just follow my cursor. There are different stars found in what we call an open cluster, which is found in the constellation Cygnus M39. So those stars come together because of the force of gravitation. And open clusters, why do we call it open cluster? Because the boundary is not very well defined. The boundary is not very well defined. And in open clusters, the density of stars is lower than globular clusters, which I will introduce after. And the stars are different. This is another open cluster of stars. So all those bright objects which you can see on the screen are stars which have come together due to the gravitational force of attraction. And this is called the Pleiad cluster. If you look carefully on this picture, you might see the wings of a butterfly. So that's why it's called the butterfly open cluster. It's a group of stars which have come together, and by coincidence, they have formed the shape of the wings of a butterfly. What you can see on the screen is a globular cluster, which is found in our galaxy, the Milky Way. Unlike the open clusters, the density of stars in the globular cluster is much higher. It also contains stars which are more older than stars in the open cluster. And globular clusters are not found in our galactic plane. They are found in a region which is much further from the galactic plane, in a region called the halo of our galaxy. You can imagine our galaxy to be more or less spherical, like a football, and most stars are found in the galactic plane. And the open clusters are found in the galactic plane, whereas the globular clusters, they are found in the halo of the galaxy. So far, during the last 50 years, we have been observing our Milky Way. Our telescopes have detected just above more than 150 globular clusters. It is possible that we have more globular clusters in our galaxy, but the sensitivity and resolving power of our telescopes have not permitted us to discover them. We hope that in the near future, maybe next 5 years or 10 years, with more sophisticated telescopes, we might discover more globular clusters in our galaxy. If you look at the screen, compared to the open clusters which you've seen previously, you can see the boundary in a globular cluster is more well defined. And the density of stars in our globular cluster is much higher than the open cluster. If you look at the next slide right now, you can see another globular cluster. It is a very famous globular cluster in the sense that it has been studied very extensively by astrophysicists. It's called the M15. You can see on the screen, just follow the cursor, you can see some kind of boundary for the globular cluster. And inside, usually at the center of the globular cluster, it is brighter, as you can see on the screen. It could be due to the formation of stars inside the globular cluster. If you look at the next slide, we see the interstellar medium. So what do we have in the interstellar medium? It is mostly gaseous. It contains mostly hydrogen and helium, and some amount of photons, some amount of ions, some amount of molecules. But it is mostly gaseous. So the interstellar medium, it is a region between the stars. So the region between the stars is not vacant. You have pictures of stars. The object which the cursor is pointing right now is a star. This is another star. So this region here is part of the interstellar medium. And part of the interstellar medium contains hydrogen with a density higher than some limit which enables stars to be formed. It also has some temperature which is above some threshold value so that stars can be formed. To summarize, in today's lecture, we have looked at different objects in our solar system. We have looked at planets, dwarf planets, minor planets, asteroids, moons, and comets. We have seen different pictures which gives us a good understanding of those objects. We have discussed a few aspects of them. We have also seen the different ways of classifying stars, the different types of stars which we have in our galaxy. Like we have stars which have nearly the same mass as ours. We can have stars which have 10 times the mass of our sun. We have seen that those stars, depending on their mass, they will die differently. In our next program, we will look at the nebulae, which are regions of hydrogen found in our galaxy, and the different types of galaxies. Thank you, viewers. We'll meet in the next program.